right, section 6.7 is about arc length. Up until now, we've talked about arc measure. Arc measure and arc length are two different things. There's a relationship between the two, but they are different. So we're going to take a look at this clock. And it asks us on the clock, what is the measure of the arc from 12 o'clock to 4 o'clock? On the clock, we know the whole clock is a full circle, 360 degrees. Well, it's divided up into 12 pieces. 360 divided by 12 is 30. All right? So we have 30 degrees, 30, 30, 30. That's 120 degrees of arc measure. So let's go down here. It says, notice that because the minute hand is longer, the tip of the minute hand must travel farther than the tip of the hour hand, even though they both move 120 degrees from 12 o'clock to 4 o'clock. So let's take a look at this a little more closely. The minute hand, that's this one. From 12 o'clock to 4 o'clock, it goes like that, right? The hour hand, though, if the hour hand were to start at 12 o'clock, it would start about right here, and it would go down to there. It's obvious that the blue arc is longer than the red arc, right? Their arc measures are both 120 degrees, but their arc lengths are totally different. We're going to take a look at 3 examples here. They're going to help us understand the formula for finding arc length. In part A, it asks, arc AB is what fraction of circle T? 1/4 is correct, because we see that we have a right angle right there. A right angle measures 90 degrees. 90 degrees out of a total of 360 degrees for a whole circle. 90 over 360 reduces to 1/4. In part B, it asks, arc CED is what fraction of circle O? We can see arc CED is a semicircle because we know CD is a diameter. Arc CED measures 180 degrees out of a total of 360. That reduces to 1/2. Part C, arc EF is what fraction of circle P? So we can see from the diagram, from the circle, that arc EF measures 120. That's 120 out of 360, which reduces to 1/3. So in part A, it's 1/4 of the whole circle. Part B, it's 1/2 of the whole circle. And in part C, it's 1/3 of the whole circle. What do these fractions have to do with arc length? If you traveled halfway around a circle, you'd cover half of its perimeter or circumference. If you went 1/4 of the way around, you'd travel 1/4 of its circumference. The arc length is some fraction of the circumference of its circle. That's the definition right there of arc length. The arc length is some fraction of the circumference of its circle. And then we have a final note here that says the measure of an arc is calculated in units of degrees, but arc length is calculated in units of distance. And of course, we know units of distance can be inches, feet, meters, kilometers, miles, right? Units of distance. As opposed to arc measure, which is the measure of an angle, that's measured in degrees. Now, if we take the definition of arc length that we've gotten here, some fraction of the circumference of its circle, And we look at our examples up above again. The fraction of the circumference comes from this, this, and this. And all three of those fractions are the same thing. 90 was the arc measure over the whole circle of 360. 180 was the arc measure over the whole circle of 360. 120 was the arc measure over the whole circle that is 360. So we can get the arc length formula by taking the arc measure over the whole circle, which is 360, and then multiplying that by the circumference of the whole circle. So now you know where this formula comes from. To use it, all you need to do is substitute in arc measure and circumference.